brightest day
and blackest night. No evil shall escape my sight.
Let's put it all together and actually go through a project where we do regression using R, using these commands start to finish. It'll probably be two videos, one video doing all the coding and the other video will have the report. Here's our kid's age versus height that we want to look at. Can we predict your height based off your age? I'm going to name it kids so that it has a different name than either of the variables in there. Here equals true. Let's take a look, make sure it read in at least. Yes, it's reading in. Does that mean there's no errors? Well, I don't know because it's actually been so long since I have looked at this. I can't be sure. It looks okay. I don't see any outliers. I don't think there's any errors. Go ahead and make us a fit and we will check the residuals. Why? I know that you can look at this and tell that there's not going to be any problem. But I want to be able to tell the client that there was a way to check that I've done the model correctly. I just see random scatter. R suggesting maybe a slight curve. It's pretty subtle if it's there. It seems okay with normality. The tails come off just a little bit, but not a whole lot. And for normality, it really does need to be in a lot before you start to worry. This, of course, looks about the same as the first plot. And there's no particular data point. You can't even see the fences that would tell you that there's a data point to worry about. I'm going to make little notes in my code as I go along so that someone looking at this later can see it. Also, it's going to make it easier to do the report. And here's the command where we're going to spend a lot of time looking at all this output. Where do my eyes go first? Right here. See that small p-value? That's 2 times 10 to the negative 16. It's basically 0. Small p-value means reject the null. Reject the null means yes, age does affect height. It's not really a shocker. Here when we plotted the data, we could see that that was the case. But go with me on this because we're setting up patterns that will still work for more complex data sets. What else do I want to look at? Here's our prediction equation, intercept and slope. So I'm going to include that in my note. Here's our prediction equation. Height can be predicted as 27.92 plus 2.5774 times age. That 2.5774 matters. It says that each age that goes up, we predict 2.5774 more in height. And that's good to know. If your kid is not gaining about 2.5 inches each year, then as a doctor, you might worry. But of course, when you're making these predictions, they aren't always accurate. You could be off by as much as 6.628 on any given prediction, or even 2 standard errors, which would be 13.256. So if a kid comes in and they are a foot over or above what you predicted, that's okay, that happens. Not super often, but sometimes. Also, we have an R squared here of 0.5107. That's not super strong, but it's not terrible either. What's the mathematical definition? That 0.5107 is a percentage, and we could say 51% of variability in height is explained by age. I don't think I spelled variability correct. Needs a T. That's not the only way you could talk about it, though. You could say R squared was 0.5107. So our predictions are somewhat good, not super great. And I realize that doesn't sound very scientific, but it depends on what kind of client you're going for. Are they a mathematically minded client that's going to want that one? Or are they more of a client that just wants a comment on the predictability? Here's where we made our plot. I can add a line to it by making age values that go from 2 to 13, I guess. And how many dots am I going to use to make this line? Some big number. Height hat. I did all the work for this already, so I'm going to copy my prediction equation here and make sure that it's using hats. Oh, age hat, height hat. And now if I do lines, height hat based off age hat, I'm going to color it red because I like red. I'm going to make the line thick so that you can see it on your screens. That's great. I have a line on my plot. I think it looks nice. Some last little details. Conf_int gives me a confidence interval for that slope. So how much a kid should grow per year? Somewhere between 2 and 3 inches. Or at least that's the average of what we expect. I also want to do a histogram of the height values here because in the next video I'm going to write a report, and it'd be nice to be able to say these were the kinds of heights that we measured.